right, here we go. A monomial. A monomial is a number variable or product of numbers and variables. A polynomial is a monomial or sum of monomials. You guys remember from Algebra 1 that if you had two terms, you call that a binomial. And if you have three terms, it's a trinomial. When you have more than three terms, it's called a polynomial. And then I didn't have enough space, so this blank here is what's up here. That's just the formal definition of a polynomial. Let me use my fancy highlighter here. And in a polynomial, what's really, really important is that you realize that the exponents are whole numbers. So I want to give you a couple examples that are polynomials and some that are not polynomials. So for example, if I give you f of x equals 3x to the fourth minus 2x cubed plus 1, that's a polynomial. Here's another one. F of x equals 5x minus x to the 8th. That's a polynomial. Here's a non-example, and I want you to try to figure out why it's a non-example. Why would this one, 3x squared minus x to the negative 1, not be a polynomial? Elena? Good. A whole number, okay, it says here in my highlighted part, exponents are whole numbers. Whole numbers are 0, 1, 2, 3. They're not negative numbers, they're not fractions or decimals. So that one's not a polynomial. Okay. What's wrong with this second non-example, Henry? The pi. Pi is an exponent, and that's not a whole number, okay? All right. Then in the next set of definitions, it says for this function, a sub n is called the leading coefficient, and n is the degree. Okay, that sounds pretty confusing, but let me really make this simple for you. A sub n just means what's the coefficient in front of the highest exponent. So if we look at my two examples, 4 is the degree because it's the highest exponent. 3 would be the leading coefficient. In my second example, 8 is the degree because it's the highest power. The leading coefficient is in front of that degree term. So what number is in front of the x to the 8? Negative 1. Good job. Good catch on that. Okay? Standard form is a polynomial that's in descending order. So let's look at a couple more and talk degree and leading coefficient. So what if I give you 3x to the fourth minus x cubed plus 5x plus 2? What's the degree on this one? Noah, what's the degree?
I don't know.
Okay, degree is the highest exponent.
4.
It's 4, right? And then McKenna, what would be the leading coefficient? If the leading coefficient is what's in front of the degree term.
3.
It's 3, okay? So, and this is descending order, so that's considered standard form. Okay? Does everybody have all that filled in? All right, good. Okay. Now we have this table. I just wanted you to cross out. We're not the standard form. It's in your textbook if you want to look at it. But we've already looked at the first 3 of these already up to this point. A constant would be like f of x equals negative 14. The graph is a horizontal line, okay? So if you have degree 0, that's just like y equals 4, y equals negative 2. It's a horizontal line, it's degree 0. Linear, boy, you've spent a lot of time in Algebra 1 with lines. This could be like f of x equals 5x plus 2, mx plus b. And it's a slanted, or what we refer to as an oblique line. Quadratic, you know this one. This could be f of x equals x squared minus 2x plus 3. That's a parabola. Now what's new for us is a cube, the cubic. A cubic we're going to learn about tomorrow has this general shape. And then a quartic is a 4th degree. And this one, and both the cubic and the quartic are much more complicated than what I've drawn, but as maybe a parent function, your even ones look like parabolas, but they can get wiggles in the middle, and we'll see those. But for now, that's the general shape. So let me give you a head start on example 1, because I feel like I've defined this well for you. I want you, on all 4 of these, to decide whether the function is a polynomial function. So you're going to write yes or no. If it's no, you're done. You don't do any more to that problem. If it's yes, write it in standard form. That means in descending order. State its degree, type, here's the type, constant, linear, quadratic, cubic, quartic, and the leading coefficient. Okay, so try all 4 of those. So let's look at letter A. Yes or no? You guys just look out of it like you're not even with me. Hello? Is there? Yes or no? Is it a polynomial?
Yes.
Yes. Okay. It's in standard form, right? This one's in standard form, so it's already standard form. Okay, what's the degree? 4. So that makes it quartic. And leading coefficient? Hey, there's no number in front of x to the 4th. It's understood to be a 1, right? Okay. All right, letter B. Yes or no? I see no. I'm on B, right?
Yes.
It's actually yes. What? Okay, Jaslyn, you were shaking your head no. What made you think it was no? Okay, You said square root
pi.
3 and the pi. Okay, now wait a minute. Let's go back to the definition. It says the exponents are whole numbers, but everything else are real numbers. Isn't square root 3 a real number? It's not imaginary. Pi's a real number. This exponent's a 1 and that's a 2. That's okay. So it's actually yes. Standard form, you have to put the highest power term first. Excuse me. So g of x is pi x squared plus 7x minus square root 3. The degree is 2. It's quadratic. And my leading coefficient is pi. All right, how about C?
No.
That's a no. Why is it no?
Because it's 3x and negative 1.
Okay, you can't have a negative exponent. And then how about D?
That's
It's no. Why?
because you don't know the x's.
The exponent, okay, all the bases, I mean, you can have a constant 2, but you can't have a 2 to the x because we don't know what x is, okay? All right. Now, example 2 says use direct substitution to evaluate f of x equals 2x to the 4th minus 5x cubed minus 4x plus 8 when x is 3. Now, I've already erased the sideboard here, but do you remember on the warm-up? 1 and 2, that's direct substitution. That's what you've already known how to do since Algebra 1. So, direct substitution means everywhere that you see x, you're going to replace it with 3. Okay, well, please excuse my dear Aunt Sally. I have to do 3 to the 4th, which is 81. 3 cubed is 27. And I got 23, okay? Now, something that I know that you guys have struggled with this year is sometimes wondering, what am I being asked to do? You're struggling with understanding the directions. So direct substitution means you just plug in that x is 3 everywhere. And so then the second thing you're going to be asked to do in this section is something called synthetic substitution. It's really rather fun once you get the hang of it, but on the next quiz, on your homework, you're going to be asked sometimes to do direct substitution and sometimes synthetic substitution. So I'm going to show you the two methods, but you have to figure out a way to keep them straight in your mind. And you might want to mix up problems with different sets of directions and see if you really do understand what does each one mean, okay? So synthetic substitution says another way to evaluate a function is synthetic substitution. However, it only works when dividing by x minus a number. It does not work if there's 2 times x minus a number. It doesn't work if there's an x squared. It has to be x minus a number. So it says in example 3, use synthetic substitution to divide x to the 4th minus 10x squared minus 2x plus 4 by x plus 3. Well, I can rewrite x plus 3 as x minus negative 3. And then I need you to just stay with me for at least 2 or 3 of these examples, because at first you're probably going to go, huh, what are you talking about? What are you doing? Because it's very weird. It's different. So what's going to happen is whatever C is, okay, whatever x minus the number, not the minus, okay, the C goes in the box. So do you see C is actually a negative 3? So it goes in the box. And then what you're going to do is you're going to list the coefficients of of the polynomial of the x to the fourth minus 10x squared minus 2x plus 4. Does anybody want to try to make a guess as to why I put a 0 in this row when there was no 0 in the polynomial? Carmel?
Because you don't have x cubed.
Okay, good job. That's it exactly. Whatever that degreed term is, if there's missing a term, you have to insert zeros. We need a place for each one of them, okay? Now, you're going to leave a row of space for a row of numbers, and then you're going to draw a line, and then you're sort of going to draw a box that's going to be under the final number, okay? So just be patient and wait to see how this unfolds. So then what you do is you bring down the first number. You always do that. Always bring down the first number. Then you take the number in the box times that first number. So negative 3 times 1 is negative 3, and you put it in the next column. The next column. Then you add the column. So that's negative 3. Then you repeat. Negative 3 times negative 3 is 9. Add the column. Negative 3 times negative 1 is positive 3. Add the column. Negative 3 times 1 is negative 3. Add the column. Now, we're going to do the division, and then we're going to use synthetic substitution to evaluate, okay? We're going to do two things here. Right now, we're asked to divide the polynomials. So, I've really taken an x to the fourth, blah, 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 divided by an x to the first, blah, blah, okay? Now, based on our exponent property, what's an x to the fourth divided by an x to the first? It's an x to the third, okay? So what this means is this bottom row here is the result of the polynomial division. So this is 1x cubed minus 3x squared minus 1x plus 1. And then the number in the box is the remainder. And because these are polynomials, you need to put an addition sign. If you don't, it means times, and that's not what we mean. And then it's 1 divided by, and we were dividing by x plus 3. So this is the answer to dividing the polynomials. Now, what if I ask you an additional question? And if I say, use synthetic substitution, and I want you to write this down. Use synthetic substitution to evaluate f of x at x equals negative 3. And we're going to call this big polynomial f of x. So what's so cool about synthetic, this is what we're doing is synthetic division right now, but the synthetic substitution, do you see there's negative 3? The answer to f of negative 3 is the remainder. This is mind-blowing. I don't know if you get this. We just did this fairly simple setup, and this is a second way to do something we already knew. We know how to plug negative 3 into that polynomial, right? That's called direct substitution. But I can do synthetic division to actually get the answer. I think this is way faster. Now watch this. Go to your graphing calculators for me. And I think I still have mine up here. Go ahead and plug in. I'll do second under so you can see it again. If you plug in parenthesis negative 3 to the fourth minus 10 parenthesis negative 3 squared minus 2 times negative 3 plus 4. That's direct substitution. It is 1. And we got it by doing synthetic division. Isn't that cool? That is really neat. And what you're going to end up finding out is as we continue to move through mathematics, synthetic division ends up helping us in a lot of other ways. Okay? All right, so let's try another one, okay? It says use synthetic substitution to divide. So we are going to divide. And now, what is C? It says it's x minus C. So what is C? It's not negative 5. It's 5. So we're going to put 5 in the box. And then we have 3, negative 17, 15, negative 25. You leave a row and then you make your box. So we're going to go through the process again. You bring down the first number, which is 3. 5 times 3 is 15. Add the column. 5 times negative 2 is negative 10, which is 5. 5 times 5 is 25. So I have a remainder 0, which means it went in evenly. That's nice. Now, you have to look at the original polynomial. It was x cubed. And now it's a bunch of other terms to it, but the degree term is x cubed. And I'm dividing by an x to the first. So what degree is the result of the division? X squared. So my answer is 3x squared minus 2x plus 5. So if you're asked to do synthetic substitution to divide, this box is your answer. Now, I want to do something else, and I want you to use synthetic substitution to evaluate, and we're going to call that polynomial f of x at x is 5. Okay, we'll call this f of x. So what's f of 5? Did anybody pick it up on the first example? It's the remainder, so it's 0. Okay? So then, in example 5, if you want to use synthetic substitution to evaluate, this is not in the x minus form. So you would actually need to subtract the 3 from both sides. So what is C? 3. So we're going to do 3. Then we do 2, negative 5. Now do you understand why I put a 0 in there? Okay, there's no x squared. Alright, so let's see. This was our third one now. Let's see if we're getting the hang of it. Bring down the first number, so it's a 2. 3 times 2 is 6. Add the column. 3 times 1 is 3. Add the column. 3 times 3 is 9. Add the column. 3 times 5 is 15. Add the column. Now, do you guys understand? It did not ask us to divide it, so I don't need to do an x cubed answer. You guys understand that? Okay. So then my answer is f of 3 is 23. The only reason why on the other two I did the substitution was to practice ahead. Okay? All right, try the next one on your own. Try example 6 the whole way through.
I have a question.
Yes.
Can you explain like the division part where it's x cubed minus x1?
Yeah. Do you see, it says you're really trying to take this polynomial divided by x minus 5. So what I'm trying to get you to see is if you're taking an x cubed divided by an x to the first, with that exponent property, you would subtract the exponents. So it's x squared.
Alright.
Does that make sense?
I'm just wondering where the x to the first came from.
It's because x minus 5, that degree is 1.
Okay.
Yeah,
Alright.
yeah, so, I mean, all I'm doing is saying x is x to the first.
Okay.
Yeah. Now, you guys, something I want to mention, none of our examples did this, but in case it happens in your homework tonight, if there is no constant, you need to put a 0 for the constant, okay? Like if the polynomial was 5x cubed plus x squared minus 7x, and you're putting those coefficients down, you need a 0 at the end, because there wasn't one. did you guys get that f of 2 is negative 49? This is fun. I mean, this is actually fun to do these once you get the hang of it.